Welcome to this session. In this session, we will see the advantages of SI unit or SI system over other three systems of unit or other systems of measurement. So let's begin. So here we will see the importance of SI. Why do we prefer SI over other systems of units? So this is very commonly asked question, and one must know why we must adopt SI system and why this is more advantageous. Okay, so if we talk about this, we can say SI is internationally accepted system. This system is rational. This is a system of units, uh, as it gives only one unit to a particular physical quantity. And it is advantageous because this is an absolute system of unit. There we don't use gravitational units on this kind of system. That we never use that small g acceleration due to gravity anywhere when we apply SI. Then this is metric system, means this carries the multiples and submultiples of units with using the power of 10. And this is coherent system of unit, because uh, it is fully based on fundamental unit. It never depends on derived unit or other forms of units. So these are the reason why we consider SI is more advantageous over the other systems of units. So quickly I'll write all these points. So as I said, number one, it is internationally accepted system. Okay, so we can write here, it is internationally accepted system. So this is the first reason, because there is no confusion over applying SI system. Everywhere you go, anywhere in the world, this system is accepted. Like a unit of length as meter. So you go anywhere, you'll find the what called the common use, the way how we measure length. The unit what we use there is meter only. So there is no confusion over it. Number two, it is a rational system of unit. So it is a rational system of units. Why? The reason is we use only one unit to a particular physical quantity. Suppose I use one particular SI unit for particular physical quantity. That particular unit I cannot use for other physical quantity. So that's why this is rational. Okay, so let me write here, rational system unit. We assign only one unit to a particular physical quantity. So this is rational. So example, if we talk, if we talk about the unit of suppose energy, so the unit of energy, SI unit of energy, we know it is joule. So this uh, the unit joule we cannot apply, we cannot use to other physical quantity. Okay, so this will remain same. So that's why what call this is rational. Number three, we can call it advantageous because it follows metric system. So I can write it is a metric system. Means we assign or we use this unit in terms of powers of 10. Okay, so it's a metric system. And so we can say the multiples and submultiples of units are expressed as power of 10. Okay, like if I want to write 1000 kilometer, 1000 kilometer, suppose 1000 kilometer, I can write 10 to the power 3 kilometer, and accordingly if I want to change this kilometer to meter, I can do that. Okay, so this power of 10, okay, this, so multiple of 10 or submultiple of 10 we consider. So that's why this is a metric system. Then fourth number, if we see, we can say this is a coherent system of unit. Okay, so it is a coherent system of units. Why? Because this is fully based on fundamental unit. It do not uh, depend on derived unit and other. So this is fully based on fundamental unit. That's why this is coherent. Uh, it is based on a certain set of fundamental units. That's why this is coherent. Okay, then number 5, if we talk the fifth one, we can say this is absolute system of unit. It is an absolute system of units, remains same anywhere. So it never depend on gravitational unit on of system. Okay, so there is no gravitational units on the system. We never use gravitational units on this system. Okay, so so these are some important point factor which makes SI more advantageous in compared to other systems of measurement or other systems of unit. Okay, so this is very important thing. So even in examination, you get this. You get one question on this particular topic. So this is how we can say. Okay, we can tell that this is the reason why SI is more advantageous. Now after knowing this thing, now most of the thing we discussed about the systems of measurement. Now let's see some relation among the units and some the units which we use for measuring a very huge quantity as well as uh, very small quantity, macro and micro quantities or measurements. So that is also which are very practical practical in day-to-day life, or uh, you'll find a lot of application of this particular units in even in other part of physics. So let's try to learn about those very important practical units. Okay, so let's see. We'll write here. Next topic will be right here. Some important practical units. Okay, let's see this. Some practical units which we use in measurement. It may be your length measurement, mass measurement, time measurement, or any of those physical quantities. But here mostly we now in this particular topic we will discuss about the length measurement for macroscopic quantity as well as microscopic quantity. Okay, so let's try to see a few of them. Okay, so let me divide this into two parts. One is macrocosmic measurement, we call this is macrocosmic measurement. That means this is the measurement which we use or which we adopt in measuring the length or distance out of planet Earth. Means we can use this in the entire cosmos. Okay, and then in universe measurement of like measurement distance between the star, between the planets, satellites, and also this is very huge, very large distance measurement units we will see now. And second one will be your micro measurement. Okay, this will be microscopic measurement, we can say micro quantity measurement. And then mainly we are talking about distance only. Okay, so the length, micros, or simply write micro distance measurement. Measurement. So these two topic will see units on these two topic. Okay, so the first one for this microcosmic measurement, this is very huge, very large distance measurement. So when you talk about this macrocosmic measurement, cosmic means related to our universe. Okay, this is the first one. So here we deal with the measurement of very large distance. In this measurement, we measure very large distances, very large distances. Okay, so the first unit which we use here is your astronomical unit. So number one in this category is astronomical unit. In short, we use AU symbol, capital A, capital U, and this is very common, very important unit. Okay, this is nothing but one must know, as a science student you must know astronomical unit means the average distance is a length distance between sun and the earth, or we can say center of the sun to the center of the earth. So that distance we call astronomical unit. So let me write here the average, okay, the average distance, the average distance between the center of the earth, between center of the earth and center of the sun. This is your astronomical unit, or one astronomical unit. Okay, it's known as that. Yeah, this is how we define the average distance. It's not the exact but average. So so here we write that is 1 AU. This is very important relation, and you must memorize this value. It will be good for you if you remember, if you memorize this value. 1 point, it is 1.4, yeah, it is 496 approximately. This we use. We'll get some more. 10 raised to power 11 meter. See, 10 raised to some power. This is metric system, and this particular thing, if we write in a proper way, when we round off this value, you will get, so in most of the book you will get 1.49 or 1 point. This can be rounded here as 1.5 into 10 to the power 11 meter. Okay, so this is the first relation you should remember, and this is very important because this is frequently used in calculations. Okay, so in many cases these values will be provided to you, but in some cases the value may not be given to you, so you should remember this, you should memorize this value. Okay. Okay, so this is the first practical unit which we use in macroscopic measurement, or large, very large distance measurement. So this is the distance between earth and the sun. Okay, now second number will go to light year. This is another unit which is not new for you. This is already you learn in lower classes. Light year. Light year is defined as the distance traveled by, the distance traveled by light in vacuum in 1 year. So that is known as light, 1 light year. So let me write here the distance traveled by light in vacuum space, vacuum in 1 year is known as 1 light year. Okay, that we know, and this can be easily calculated. This, I think, in lower class also you might have calculated this particular distance. Let's try to learn now. Yeah? Let's try to learn this thing. So we know this is a distance, so there's a relation, speed equal to distance divided by time. So this relation we will make use here to find this distance covered by light in 1 year, or what, how much is this distance. 1 light year is equivalent to how much meter or kilometer. That part we can find out using this relation, speed distance divided by time. Why? Because speed here, speed is, we'll consider speed of light, in vacuum, and then this time is 1 year. So because here these two data we know, speed of light in vacuum and the time is 1 year, so using these two we can find out the distance. Okay, simple concept here. So here we know speed of light, the velocity of light in velocity of, since velocity of light in vacuum, that is 3 into 10 to the power 8 meter per second. This is the data that everyone knows. And here time time taken is 1 year. Okay, 1 year. Now this 1 year we can easily convert into what? See, if you see here, this is meter per second. So this 1 year we can convert into second. So this is nothing but 365. This is the number of days in a year. Then you convert day into hour. So 24 hours in a day. Now hours into minute, 60 minute, and then minute into second, 60 second. So this data will help you to convert 1 year into second. Okay, second. Now if I solve this, this will give me the number of seconds in 1 year. Now this value and this is velocity of light in vacuum and time taken, that is 1 year in terms of second. If I multiply, say, speed into time, velocity into time will give me the distance. So I can easily write here, therefore distance. Okay, distance means what? 1 light year. So 1 light year is nothing but product of these two, 3 into 10 to the power 8 into this whole, 365 into 24 into 60 into 60. Now see, this second and this second will cancel each other. If I'll show you here, meter per second, this is the velocity, into time is second. So second will cancel each other. So meter only will left out. So this will give me meter. And if we calculate this, let me try. 365 24 into 60 into 60. So this gives 9.46 into 10 decimal. If you see that, yeah, 8 already here, so 7 there. So it is 15 meter. Okay, so I can write here 1 light year. 1 light year is 9.46 or 9.5. It depends on the book. So let me use this only, 10 raised to power 15 meter. So this is the relation I got between light year and your meter. In light year, in 1 light year we find almost 9.5 10 to the power 15 meter, and same thing we did earlier. 1 AU was 1.5 into 10 raised to 11 meters. So if you see here, we can easily make out light year is bigger unit than astronomical unit. Okay, now we'll move on to the third practical unit which we use, that is called parsec. Okay, so let me write here. This is parsec. So this abbreviated form actually. So the full form of this parsec is parallactic second. Parallactic seconds. Okay, so this is the full form of parsec. Now let's try to know what is this. This parsec. Okay, so let's try to know what is this particular unit. Now for this, we should remember, we should understand. Let me explain you through a diagram. Uh, this actually, let me first tell you what is parallactic second all about. It is a distance at which an arc of 1 AU long forms an angle of 1 arc second. Okay, again let me tell you. Suppose there is an arc whose length is 1 AU. 1 AU already we discussed earlier, 1 astronomical unit. If the if the length of an arc is 1 AU, and that arc, okay, forms an angle of 1 second, 1 arc second at the center, then that particular distance we call 1 parsec. Okay, let me explain again. If suppose this is, if I take this as a circle, the concept of arc and radius, suppose this is the radius, now this is arc. Now if I consider this arc, okay, this arc A, B, O, if I consider this arc AB is of length 1 AU, okay, and this arc makes an angle theta here at the center of the circle. So this theta, if this theta is found to be 1 arc second or 1 second, this is of 1 second, okay, 1 second angle. If theta is 1 second, then this distance OA, this radius OA or OB, this radius will be 1 parsec. 1 parsec. Okay, so let me explain you here. If I consider, okay, if I consider this center of the circle, and if I take this as A and this as B, and this is the arc, this is the arc, okay. If this arc now we can think about the circle here. Now we can think about one circle over here. We can think about a circle. We don't need that circle, just one idea only. Now this arc, which is making angle theta here, no? Now this is the radius, we know, and this is the length of the arc. This is theta, we know. This was the relation. This is how we define the relation between length of arc, radius, and the central angle formed by the arc. Now what I said, if this arc length is 1 AU, okay, and this angle formed at the center by this arc is 1 second, 1 arc second, 1 second, we use this, see, degree, this is 1 degree, then this with 1 inverted comma, this called 1 minute, and this with this 2 inverted comma we call 1 second, or this is also called 1 arc second. This 1 minute is also called 1 arc minute, okay. Yeah, this we'll see a little later, this calculation and all. Okay, so this is the situation in front of you. Now in this case, if I what I said is, if my length of arc is 1 AU and that arc makes 1 second angle at the center, then this radius of the circle will be called 1 parsec. 1 parsec. Okay, so this is how we define 1 parsec. Okay, now let's come to this. So definition you got. Let me define it. Define here the distance distance at which an arc 1 AU long, this is the length of the arc, 1 AU long, forms an angle of 1 arc second, that is this one, at center is known as 1 parsec. Okay, 1 parsec. This is how we define. Okay, so it is clear from the figure here. This figure explained. Now let's try to find the relation between 1 parsec and a meter. So this is very important derivation, so try to understand properly. We know since here this length of the arc, that is L here, L is 1 AU. Okay, and we know 1 AU, just in our previous discussion we found 1 AU here 1.5 10 raised to power 11 meters, so that we can use here 1.5 into 10 to the power 11 meter. Okay, so in terms of meter I wrote. Now what about theta? And we know this central angle theta is 1 second, 1 arc second, 1 second. So now this second we'll try to convert it into radian, because remember in SI, whenever we deal with SI, your angle must be in radian. Why? Because we are using length to find this. We are comparing length to find theta. Okay, so that's why, and that there is also in meter we are using. So this 1 second, 1 arc second, we can write 1 divided by 60 minute, that we know, minute. Okay, now this minute will convert to degree, and then only degree we can convert to radian, that we have seen here in our previous class. So this will convert to degree. So 1 divided by 60 into 60 degree. So that's why this relation one must know that okay, so what I did is, see, this is how we do 1 minute, there's one comma, this inverted comma, is equal to 60 second. This is 60, this second symbol. All right, and then we must know 1 degree. 1 degree, this is comma, degree is 60 minute. So 60, sorry, 1 only 60 minute, this relation. Okay, so this relation I applied here. If 1 minute is 60 second, then 1 second will be 1 by 60 minutes. So 1 second is 1 by 60 minute. Similarly, 1 degree is 60 minute. So 1 minute will be 1 by 60 degree. So that's why this 1 by 60 minute I converted to degree by dividing 60 here. Okay, so this is, we must remember this whole thing, this everything, this second, minute, then degree, this thing you will learn in mathematics, class 11 mathematics, in your trigonometry chapter, chapter number 3. So there you will learn how do we get this unit. Okay, so there you'll get chance to learn about all this thing. Okay, now move on to next. Now after this we can yeah, this is after this step, degree. Once I get degree can be converted to radian, and for that also we know, let me write here, 1 degree. 1 degree is equal to, if you remember this we discussed in our previous class, 1 pi by 180 radian. Okay, this radian. So this all will keep together. Now I'll convert this into radian. This equal to, here, 1 by 60 into 60. This all are in degree. Now I want to convert it into radian. So into this value, pi by 180 radian, and now this all unit will get converted into radian. Okay. Okay, so this is done. This is the value of theta we got. So this simplification we can do easily. Here you can replace this pi by 22 by 7 or 3.14, and rest you can easily do that calculation. Now after having known these two things, length of the arc and theta, the central L and theta, now we want to find this R, which is to be 1 per sec. So let's try to use that relation. Now we know the relation. What was that? What was that relation? Relation was theta equal to length of arc divided by radius of the circle. This relation we know. Now this relation will help you to get the value of R, because we want to know this R. Okay, so let me write here only, R will be L divided by theta. Now both L and theta we know, we can replace here. So let me write here, L is 1 AU and theta is 1 second. Okay, arc second. Now replace their actual value. 1 AU was 1.5 into 10 to the power 11 meter, and this 1 second we got here, 1 second, just now we calculated this much we got. So it's pi divided by 60 into 60 into 180. Use value here, this much radian. Okay. Now when we simplify this, you will get, if we go further, I'm using this relation. Okay, so let me continue here. And what is R? 1, this R we assumed as 1 per sec. So I can write 1 per sec. Per sec equal to 1.5 into 10 power 11. This all will go to numerator, 60 into 60 into 180 divided by pi. Pi is 3.14. Okay, so now if we do this calculation, we find 1.5 into 60 into 60 into 180 divided by 3.14. Here we get here 3, yeah, we can round off 3.1 and decimal, yeah, so this decimal will be, so we get here 3.084 something into 10 raised to 16, yeah, power 16. 11 here and 5 from the decimal, we get this much meter. Why? Because this radian, radian, here we don't require this radian here, so this all will give me, because radian is a ratio only. See, if you see, it's a ratio. That's why it's, many time student they get confused. We here I wrote meter directly. I wrote meter. Even at the last step I wrote meter, this meter, but I did not use this radian. So radian is not missing here. Actually, radian is nothing but ratio of two length, arc length divided by radius. So when we cancel them, so you'll get without any unit. So that's why radian is simply a ratio. That's why we ignore that. Okay. Now here I can write 1 per sec. 1 per sec, okay, is equal to, now we can round off, 3.1 into 10 to the power 16 meter. So we found all these three important practical units which we used in length measurement, large distance length measurement, okay, very large distance. So we found 1 per sec as 3.1, 10 to the power 16 meter. Now if we compare all this thing, AU was in the range of 10 to the power 11 meter. A light year is in the range of 10 to the power 15 meter, and now parsec is in the range of 10 power 16 meter. So if you see, parsec is more bigger unit in compared to light year and AU. Okay, so these three we learn now. Now we can, now if you want, you can easily compare these three units to get their actual relation. Okay, so let's we can make out easily, so there is no hard and fast thing. So if you compare light year and AU, you'll find the difference of around 10 power 4, 10 power 4, 10 power 3 meter, 1000 times no, difference there. So compare, when you compare with this light year and parsec, you'll find hardly, this was 9, 10 power 15, 10 power 16, difference of 10 times only. Okay, so we can easily compare these three units of distance measurement. Now this is for the large unit distance measurement. Now if we talk about small unit, or is that what called a small unit, you'll find that some units are there which we must know, that is small unit, microscopic or small distance units. For this we have a few there. So this also one must have idea. 1 micron, this is 1 micron. Now 1 micron, we used to write 1, this is 1 micron means 1 micrometer. Okay, so let me write here, 1 micron means 1 micrometer. So 1, we use this symbol mu, okay. 1 mu or mu m, micrometer. This is 10 to the power minus 6 meter. This relation we must know. 1 micron, micrometer, okay. 1 micrometer is 10 to the power minus 6 meter. Then we have nanometer. 1 nanometer, this is 1 nm, is equal to 10 to the power minus 9 meter. This also one must remember, for calculation we need this. Number 3, 1 angstrom, this is 1 a with this 0 in the power degree type, 10, this minus 10 meter. So this we use to measure the size of atom. Number 4, 1 Fermi. This also called femtometer, 1 femtometer. Okay, so this is 1 small fm is 10 raised to power minus 15 meter. This is the smallest unit we consider. Some more are there, like picometer. No? So that also, let's try to write. 1 picometer, 1 pm, this is 10 raised to power this minus 12 meter. Actually this should come before this Fermi. Anyway, so these are some other units which we use practically in numerical questions. So this is how we express units for large distance measurement, very large distance measurement, and small distance measurement. Okay, so today I will wind up here only, and then in our next class we shall see some calculation based on these units. Thank you.